Hey everyone, I'm here with Dr. Lane Mears, who's the chair of the Automotive Engineering Department at Clemson University, and I'm in the Vehicle Assembly Center. Dr. Mears, will you tell me a little bit about the Vehicle Assembly Center and what you guys have going on here?
Sure. So we're here in the Vehicle Assembly Center. It's a vehicle assembly hall with a full-size vehicle, and the point is that we can come in here, we can try different technologies for vehicle assembly, and we can mess things up. And we mess things up on purpose, which you wouldn't want to do in a regular factory. The reason we chose vehicle assembly is that we have technologies like robotics, sensing, and other types of assistive technologies. And we have people. So there's people in the assembly operation, and there will always be people in the assembly operation, at least while I'm in the business.
Okay, give us a quick overview of what we're looking at here. We have a vehicle behind us. It's a Mini Cooper, and how are you guys using the Mini Cooper? And we're also on this little platform here. I'll step back so people can see.
Yep.
There's a little platform here. So what exactly is the platform, the vehicle, and some of the robotics we're seeing around us here?
So it's a great question. So this platform actually came out of an original equipment manufacturer shop where they build vehicles. And so we use all of the same technology that's used in the original vehicle shop. The Mini Cooper is a special Mini Cooper that was designed and built by BMW. It's an electric Mini Cooper. It's actually one of the precursors of the i3 vehicle.
Okay.
And so we're looking at assembly operations and assembly technologies that would be applied to electric vehicle assembly, because we see that coming up more and more in the market these days.
And what are some of the the robotics we're seeing here? There's a lot of sensors and some speakers and a bunch of other laboratory equipment in this room.
Sure. So what we like to do is we like to use the same types of technologies that you're going to find in the factory. So the same types of data-enabled tooling. So here we can have assembly operations that are happening with data and tracking of the tool and the person. And we collect that data through an internet system here, and we can do large-scale sort of analysis of the type of data. We use the same type of automation that you might find in an assembly hall. So robotics, I'm sure a lot of people have heard about some of the disasters of trying to take all of the people out of the assembly operation. We're going to replace them all with robots. Doesn't really work. There are places for robots, and there are places for people, and there are places for robots and people working together on tasks. There are some things that robots do well. There are some things that people do well. We explore some of those technologies here.
Okay, in addition to Dr. Mears, I'm here with Dr. Matthew Crew, who's a research professor here at the Vehicle Assembly Center. Dr. Crew, tell me a little bit more about what you and the students are doing here.
So we're doing a lot of work here around vehicle assembly, as you heard from Dr. Mears, but we're also doing that to give students experiences with hands-on. So you saw the battery lab. You're also moving with one of our vehicles right now. So we also have them work on a full-size vehicle, as well as with many of the tools that they're going to use, such as torque fastening tools. We put them in the environment where we have a lot of those same industrial control systems, the PLCs, the Atlas Copco fastening tools. We have computer vision systems as well as real-time locating systems. So we're bringing them and giving them access to a lot of the technology that they're going to see in the factory of the future. And we're trying to make that the factory of today here in our lab.
So we're on this platform, and this was brought in, adapted from the actual manufacturing floor,
Yes.
right?
So we brought this entire platform out of BMW, so we can also have that exact same stance where somebody's working, and now they have to move to this moving platform to work alongside the vehicle. So the platform moves alongside. If you go into a vehicle manufacturing plant, you'll see a very similar setup of how the workers are actively working. And we do that because we want to be able to test things like new robotic systems and new tooling systems in the same environment that they're going to be tested in the real world and used every day. And that allows our students to mimic the real world, but we can mimic it safely. We don't have costs from production. We can shut this down. We can shut this lab down, move it faster. We can speed it up, slow it down, without impacting things that would be critical to production processes.
What do we have here? This Mini Cooper. Maybe will give us a little bit more detail on how this Mini Cooper moves through the assembly plant. It looks like there's the engines removed on this Mini Cooper.
Yeah.
So give me a quick overview of what we have here, and is this, let me see if I can lift this up.
Yeah, so this is actually an early prototype of an electric vehicle. So when electric vehicles were first being designed, this was designed by BMW engineers. We use this now as an example of assembly operations that could happen with electric vehicles, particularly the batteries. So how do we put together batteries And then how do we take these battery modules and install them to the vehicle in a way that's safe for people, both electrically safe and ergonomically safe, and in a way that minimizes cost and keeps the product moving through the line. We can look right behind us here. This is actually, we're setting up a sub-assembly area for battery manufacturing. So we can explore how do we take batteries and put them into bricks, and put those bricks into blocks, and put those blocks into modules, and put those modules into packs. Then you have a battery pack that's the type of driving energy that's used in the electric vehicle. So we look at the individual assembly operations here. This could represent a line-side assembly operation, a sub-assembly operation. It can also represent a separate supplier that transmits materials, transmits data to the assembly hall, and then how do we bring those batteries in here, and what types of technologies might we use to go up and install the battery on the vehicle.
Okay, and tell me a little bit more about how you guys simulate the manufacturing processes. I see a bunch of speakers here, a bunch of sensors here. Am I right that you actually have recorded the sounds from the manufacturing floor, and we can recreate that environment by playing the sounds here through this like high fidelity speaker system?
Correct. So a big part of that is we wanted to mimic what it's like to actually be on the factory floor. It's very quiet in here right now, but if we go ahead and we turn on the speaker system, we can hear what it actually sounds like. So we went out and we recorded using binaural microphones what it sounds like to stand alongside of the assembly line and work on that line. And so we give people that emotional connection, not just through the physical tooling and tools that they're using, but we can also give them that connection by having them listen and hear all of the noise and distractions that they have in the real world, even down to the vehicle physically moving. So one thing that people don't realize is that we like to use things around us to know how long we have left to do our work. One of those is workers have created a progress bar because they know where their station ends and where the next one begins. And so when that vehicle gets all the way to that point, we know that they're going to be finished with that process. And so that's where we also want to have that connection to the environment as well. So everything from what it sounds and feels like, as well as the lighting inside of it, we want to mimic that as best as possible.
So Dr. Mears was actually showing us this instrument, but we didn't talk about it in detail. He kind of gave us a brief overview of how it works. Tell me a little bit more about what this is. A torque wrench. I'm familiar with torque wrench. I used to be a mechanic, but I see like a remote sensor here. Tell us a little bit more about how this smart torque wrench works and how you're using it in your research.
Yes. So this is a very fancy version of the torque wrenches that you might have used in the past or have at home. These ones are from Atlas Copco, but they are able to sense not just how much torque is being put into a bolt during a fastening operation, but also how many revolutions and rotations, but also the orientation of the tool. So if we push and pull that tool or rotate it in different ways, we can see that in the back end of the system. If you've ever had to work with a bolt and you accidentally put it into it at an angle, it might cross thread, and so we want to eliminate the need for that or for that to happen out on the factory floor. And so we've added new types of technologies in. These ones are added in by Atlas Copco. And then what we're doing is we're also adding in things like tracking systems. So being able to understand which tool is working on which fastener across the entire vehicle. So now we have a very good field of view when we go back and do any root cause analysis. If there's any problems or errors in the future, we know exactly which tool was used on it, when it was used, who was operating it. And also we know a lot about the environmental performance of what angles were they at, how much force and energy went into this. So we have a much better idea and much better data-driven understanding of what happened so that we can find that root cause and come to an improvement faster.
Okay, and as we wrap up here, I'm actually seeing one more thing that's kind of interesting. I see this like bodysuit, and it looks like it's lined with a bunch of sensors, something you might even see on like a movie studio. Tell me a little bit more about what this bodysuit is and how you guys are using this bodysuit.
So it's very good that you notice that it looks like it's out of a movie studio. In this case, this is a Rococo motion capture suit. So we're pulling in using IMUs that are inside of the suit textile itself. And we can pull that out here. So we're using the IMUs that are built into the suit itself. So we're pulling out all of the different motion information from the suit itself. We're able to capture from each of these boxes very high fidelity information about how a person is moving and flexing. And this information goes back and creates a joint kinematic model of the person. So we can see what they look like in virtual space and record their motions very accurately. All the way down to their fingertips. We have a pair of gloves that goes along with this, as well as face and motion tracking, face tracking as well. Because we want to also capture not just the vehicle systems, the robotic systems, the data systems, but also the people and we want to bring that data in. But we also want to push data and information out to people, because they're a big part of our manufacturing future, especially in the automotive industry, and we want to include them in that as much as possible.
So I know that some of the people watching this video might be prospective students, and I know currently we have a master's program here, we have a PhD program here. I'm one of the PhD students in the automotive engineering program, but we've also opened this up for undergrads recently, right? So is this one of the facilities or one of the labs where undergrads and graduate students might have the access to get some experience and hands-on work?
That's a great question. So yeah, I'll start by saying this is the nation's only Department of Automotive Engineering, and we run the nation's only bachelor's in the discipline of automotive engineering, master's and PhD in automotive engineering. We are hands-on, so we spend some time in the classroom, but that classroom time is always mirrored by time spent in the laboratory space. And as you see here, we're not in a little 300 square foot benchtop lab. We're here in a laboratory that represents what students are really going to see when they go out as engineers, managers, researchers, technicians, any of those roles that they're going to play. They're going to have experience in the technologies that they're going to see when they go out there, and the technologies that they're going to see a few years down the road. So those are some of the things that we explore.
Okay, great. And if students want to get more information, can they just go to the Clemson University Automotive Engineering website? And I'm sure there's a lot more information there, a portal, applications.
We've spent a lot of time putting a really nice automotive engineering department website together, so you can go check that out. It's got all of the information on our bachelor's, master's, PhD programs. It's got information on certificate programs for students that aren't seeking a degree but still want some of the experience, and distance learning programs, so we can have students from all over the world participate.
Awesome. All right. Well, thanks so much. Appreciate it.
All right.
Great talking to you today.
Thank you.
Thank you. Okay, bye.